For over a decade, the tech industry rewarded the full-stack generalist, the engineer who could build a front end in the morning and configure a database at lunch. That era is ending. AI is rapidly commoditizing boiler code, stripping away the market value of broad, surface-level knowledge. The World Economic Forum reports that AI is redefining career entries by automating the foundational tasks that once helped junior employees gain experience. The entry-level roadmap is no longer a match for the actual terrain of the workforce. This chart shows the compensation divergence between broad skill sets and deep expertise. While generalist salaries plateau, organizations are paying a 30% premium for hyper-specialized domains like MLOps, AI infrastructure, and UI architecture. This market pressure has forged a new profile, the super individual contributor, or super IC. This is a single engineer outputting the volume of work previously expected from a multi-person team. They achieve this scale by automating foundational chores, like generating responsive variants or checking contrast ratios, reserving their cognitive load strictly for complex architecture and systems. Major consulting firms observe that productivity improves when organizations focus on redesigning work around people collaborating directly with AI, rather than simply deploying new technologies into old workflows. Surviving this economic shift requires abandoning generalist habits. The engineers setting the pace today are mastering the specific architectural layers that scale their personal output. To see how a super IC operates, we have to look at the three-part stack they use to build a modern automation SaaS application. Layer 1 is automated quality control. They deploy AI agent skills to act as a persistent architectural linting layer that enforces standards in real time. Layer 2 is the front-end interface, which relies on advanced visual state machines and interactive node editors instead of static dashboards. Layer 3 handles back-end orchestration, combining modular enterprise authentication with durable execution to ensure background tasks never fail. By combining these three specialized layers, a single engineer can architect a platform that once required separate front-end, back-end, and QA departments. Super ICs do not use ad hoc LLM prompting. Pasting scattered instructions into a chat box is inefficient and leads to the predictable, generic AI slop that plagues modern front-ends. Instead, they use agent skills. These are localized directories containing YAML front matter, markdown instructions, and executable scripts that provide localized, persistent project memory. The challenge is memory. If you load massive design guidelines and accessibility rules into every prompt, you will exhaust the LLM's context window before it even starts writing. This is progressive disclosure. The system initially ingests a tiny snippet, about 100 tokens, with the skill's name and description. This keeps the active context lean, delaying full memory commitment. The heavy markdown file only slides into the context window when it matches the task. This is how Vercel's React Best Practices or the access length skill functions in a production workflow. The skill audits the code for WCAG 2.1 accessibility, eliminates request waterfalls, and prevents design system anti-patterns like Boolean prop proliferation. This makes agent skills a persistent architectural linter, removing the burden of manual boilerplate review from the engineer's daily schedule. On the front end, modern SaaS applications have largely moved toward node-based visual logic. Users want to connect blocks rather than filling out endless forms. Major enterprise platforms like Stripe use this visual approach to help developers map out the interactions between payments, webhooks, and API systems. In frameworks like React Flow, these nodes are not images. They are fully interactive React components, carrying embedded forms and conditional logic. But treating every node as a complex component creates a critical performance risk: uncontrolled state management. This graph illustrates the problem. In an uncontrolled state, moving a single node forces every other component in the graph to refresh, creating a sequential refresh that destroys browser performance. When scaling to a large dataset with hundreds of nodes, this architectural flaw results in a severely lagging interface that is unusable for enterprise tasks. The Super IC solves this by implementing virtualization, paired with a controlled state library to manage state independently of the diagram's visual flow. This diagram shows how virtualization renders only what is visible. As nodes move outside the viewport, they are disconnected from the active DOM, preventing the browser from wasting resources on off-screen elements.
Mastering virtualization ensures the interface maintains a steady 60 frames per second, regardless of how massive the underlying dataset becomes. A performant UI is worthless without enterprise-grade security and a backend capable of reliable execution. Instead of building auth from scratch, Super ICs integrate SAML 2.0 single sign-on platforms to handle identity. This layer allows users to authenticate through established identity providers like Okta, Azure AD, or Google Workspace. To manage this, engineers must configure one of two SAML login routing flows, IDP-initiated or SP-initiated. In the IDP-initiated flow, users click a tile on their identity dashboard to enter the SaaS, a simple setup requiring no complex routing. The SP-initiated flow starts at the SaaS app, requiring configured email domains to route users back for verification. Once the user is authenticated, the backend must ensure that the workflows they build in the front end actually finish their tasks. Code-based durable workflows maintain their state persistently. Even if a cloud server crashes mid-execution, the workflow resumes exactly where it left off once the server is restored. Pairing SAML 2.0 with durable orchestration creates a resilient enterprise backend. It offloads identity and state management, removing the burdens that usually justify a full-time backend department. Modern software is no longer about writing every component from scratch. It is about synchronization. AI agents enforce the code standards, React virtualization powers the interface, and SSO protocols secure the data. This framework allows a single engineer to ship an entire platform, replacing front-end, back-end, and QA leads. To thrive in this era of career hyper-specialization, engineers must stop memorizing basic syntax and start mastering deep architectural patterns.